Okay, good morning, good afternoon, good evening, everybody. My name is Garrett Herning from Hydra-Test. Hopefully you can all see and hear me. There we go. Okay, I've got my laptop set up here so I can actually see that it connected. This is our first time doing this, so I'm going to wait probably just a couple of minutes. We have a few people, I guess we're waiting for to jump online. So I just wanted to get things connected and say hello to everybody. So I guess if somebody out there can just reply in the chat box that you can hear and see me okay. Okay, great. Thank you. Okay, great. Yeah, why don't we wait? I'm going to wait a couple more minutes, maybe about 2 minutes here, just to see if we get a few more people. We had over 100 people register for this, so I want to see if we can get a few more online. Yes, good evening. We'll kind of see how this goes. I know there's quite a few people from overseas on this today, and what I want to do is maybe we may do this more than once, so we have one that's a little bit better for when you guys are up. It's not the middle of the night or late there, so we can do one that's late here, but it'd be more of a normal time for you guys. So. Okay, well, why don't we get started and kind of get going here. So we've got about 45 minutes to an hour is how long the webinar is going to be. So let me introduce myself. My name is Garrett Herning. I came on board with the guys at Hydra-Test here at the beginning of the year. We opened our U.S. office to kind of better support the United States and North America. So we didn't really have that before. And I've got a fair history in this industry. So way, way, way back in the day, I worked for Axiline. They make the transmission dynos back when it was based up in Green Bay, Wisconsin. After that, I worked for Zoom Technology. I'm sure many of you are familiar with them. They had the Tran-X and the Answermatic line of valve body and solenoid testing equipment. Also worked at PowerTest. So I do a lot of big on and off highway test equipment. So very familiar with a lot of dynos and stuff like that. And then came on board with the guys with Hydra-Test at the beginning of the year. So I'm very familiar with test equipment, testing valve bodies, testing transmissions. So what we wanted to do here is to kind of start some webinars to kind of help out, number one, get you a little bit more familiar with the stuff that we do in our equipment, but really just to kind of give some better, I think, information to the industry. I notice over here, especially in the US, there's been kind of a vacuum as far as equipment and testing, and people have kind of been left to do whatever it is they can do. So we're trying to kind of come around and really provide some good solutions, but also educate the industry. So that's kind of what we're going to start with on this webinar. So we do have quite a few people on the webinar. So we do have the chat window there. Kind of use the comments sparingly, just because I want to get through the presentation for any of the people that just want to get on and get off. We can probably answer questions and anything afterwards, and if you want any more detailed information, you can always contact me or our UK or overseas offices on anything. So, but what I wanted to do today, and I'll have this presentation that we'll go through, is kind of talk about valve body remanufacturing. We get a lot of calls on this stuff with people who maybe haven't done it, who are thinking about doing it, who are partially doing it, and they really want to get into it. And the first thing they always ask us is, hey, I want to get into valve body remanufacturing. How much is some equipment? And there's a lot to talk about before you jump into just buying some test equipment and starting to do valve body remanufacturing. So what we're going to do is we're going to talk a little bit about valve bodies and valve body wear. We're going to talk about kind of what I see as you need if you're going to get into doing valve body remanufacturing. And I call it remanufacturing because even if you're a shop and you're only doing maybe a dozen valve bodies or so a week, you're still remanufacturing. You're really not any different than a large reman that processes, say, 100 valve bodies a day. It's the same kind of process. You're looking at the same things. And so after we get in a little bit of that, then we'll kind of look at some example. I've got some really good examples that were provided to us by some customers on a 4L80E and a 6L80. Of some stuff that was some wear issues, what it would cause, and how we were able to see it on some of our equipment. So I think it'll be kind of interesting. It's kind of a high-level overview. As we do some more webinars, we'll probably maybe dig into, I'd like to do a case example on one particular valve body that had a bunch of issues, kind of a before and after. So, but that'll be for some other webinars coming up. This is kind of just our first one to get started. So let's talk a little bit about valve bodies and valve body wear. So valve bodies are really probably the single most complex part of a modern transmission. It's amazing how complicated they are, and they change, it seems like, every few years. There's a whole new generation of them. They try different things. Some things seem to work, some things don't. We saw the mechatronic ones several years back, and now everybody is taking the TCUs back out of the transmissions and instead of having them in there. So that's been interesting and has created a whole series of problems by itself for you guys. And what really used to be a relatively simple valve bodies, and I got a 4L80 valve body pictured here, which I kind of always use as my default case. If you're not familiar with really working on valve bodies, this is a really good one to start with. It's kind of electronic valve bodies 101. It's where they first started using aluminum as in the castings. It's got simple solenoids on it. It's got 2 shift solenoids, 1 pressure control, and a lockup. So it kind of gives you all the basics. Normally it would have your pressure switch assembly on here, so it has some electronics with it, but kind of has all of the basics when we're getting into what we call electronic valve bodies. Obviously now we got 6, 7, 8. Allison just released their 10-speed unit for in the trucks. I think Gears had an issue or an article about that in their last issue, so we've gone much more complex than this, but this is kind of a good primer to start with. And believe it or not, I guess everybody over outside of the US, we still have a lot of these in the United States here. That's been one thing interesting coming on board, is seeing the differences between what we have here in the States and maybe what they have in other places in the world. We still have a lot of older valve bodies that people are working on, and working on a lot of them. So, and the biggest thing with any of these valve bodies, because they're all the castings are aluminum, you have aluminum valves, aluminum housings, is as this vehicle is driven, the valve body experiences wear. Okay, the valves are moving in there and they're wearing in the bores in the valve body. And this wear is really where we see the issue. As that wears, we get leakage, and what happens is the valve body loses its ability to maintain and control pressure. And that's how all of the shifting and all of the actuation from gear to gear happens, is by pressure. So when we lose that ability, or when that ability is compromised, that's when we see issues. And when that happens, that's when the vehicle shows up at your shop. That's when we have codes, when it's in fail-safe, when it's not driving right, and somebody says, hey, there's something wrong with my car, I need you to fix it. So, and the problem with it is that wear is not always easy to find, and it's not always easy to see with the naked eye. Sometimes, yes, you can see it with the naked eye, but other times it's really difficult. And that's the challenge if you're getting into doing valve body remanufacturing, as opposed to buying an already remanufactured one, is you're the one that's going to go in there and trying to identify what's worn and to fix that. So that kind of brings us to what is our real goal with valve bodies. And there's kind of three things you can look at. Are we trying to build a unit that's much better than the manufacturer ever put out, that's got unmatched performance? Are we trying to just get this back to more of an OEM function, or are we just trying to get this off of our lift and car down the road? And I got pictured here a ZF6HP, which is a very complicated unit compared to that 4L80. There's a lot of expensive parts on there. The solenoids alone are expensive, much less everything else, and a lot of engineering into that unit. So I think we can all agree that last option of we're just trying to get this down the road isn't what our goal is. Our goal is we want to build a good unit that lasts a long time and makes that customer happy so that they come back again and again, with their other vehicles. But are we trying to build a really fantastic over-the-top unit valve body? Most of the time, no. And I had to kind of temper this a little bit. So there is a diesel shop that I do work with in the area here. And for those of you outside the United States, that's what's become common here is there's a lot of people here that like the larger 3/4 ton, 1 ton diesel pickup trucks. And they like to jack them up, they like to put larger tires on. What goes along with that, they also want a lot more horsepower. So they'll take this into a performance shop like this, and these guys are adding bigger turbos, they're retuning the engine, and they'll bump up, the horsepower from maybe 300 to 400 or 500 horsepower. In a case like that, obviously the stock transmission isn't going to be able to hold up. It was never designed or put together to handle that. So they're pulling the valve bodies out. They're making some very significant changes to them. But at the same time, they're also going in, they're changing the programming for that. So they're re-updating and making a lot of changes to that whole package. So they're probably the one case where they're trying to build a much better valve body or a performance valve body, even in some of these later model vehicles. Your average customer, like say myself, I'll use myself as a good example. My wife has a 2011 Jeep Grand Cherokee. It's got the 6-liter, or I'm sorry, the three-cylinder, 6-liter engine in it. It's got the Mercedes 722.6 transmission in it, I believe. We've got 145,000 miles on that. That's about the point what I consider would be the life of that transmission. So if that transmission started giving us trouble in the next couple of months, I wouldn't be surprised. If I bring it into your shop, what am I going to expect on that? If you can rebuild that transmission, you remanufacture that valve body, and I can get another 140,000 miles on it, I'm going to be happy. I'm not expecting to go in and do any reprogramming. You're going to go in, clear out any of the codes in there, reset the adapt so it goes back through and learns the transmission after it's rebuilt, and I want it to get about the same mileage it has on it now. I'm not going to probably keep the vehicle that long, so I'm not looking for something over the top. I'm just looking for something that's back to close to what it came from the factory, maybe a little bit better. There are a number of different kits out there that improve things like lubrication in the valve body, or maybe they can fix some pressure regulation issues. Maybe in this particular circuit in there, every time it shifted, you saw a drop in pressure before it came back up. We can put an aftermarket kit in that corrects that and keeps it from dropping that pressure. We're not really changing the function of the valve body so much. We're just keeping it about what the factory did because it's got to work with that factory tune. We're not going to go in and touch that. So really, kind of your goal if you're going to get into valve body manufacturing is probably this middle one. We're trying to get this fairly close, maybe a little bit better than OEM function, but we're not going to, most customers aren't going to want to go through and spend, thousands of dollars on a valve body to have something that's over the top when it doesn't warrant it. It's only in those specific cases of if you're doing performance work. So that brings us to the next point, is what do I need when if I'm going to remanufacture valve bodies? And a lot of people, they call us up, and the first thing they start asking about is test equipment. How much does it cost? How quick can I get it? Is it expandable in the future? All that kind of stuff. And that's where we stop and we ask them, are you doing valve bodies now? Have you much experience with it? What are you looking to do overall? And the first thing I will say, and I've seen this, I've got a really good example of what happens if you don't. When I was at Zoom, we did a valve body test system for a customer, and the biggest thing is you have to have good technicians. You have to have technicians that can learn these valve bodies, that can learn the wear characteristics and understand how to use everything from the tools to test equipment. We had one customer, we put in a valve body system. When I was at Zoom, this was quite a few years ago, so it was an answermatic machine, a solenoid machine, a shifting system. And they had it for about 3 months, and they called us up, and he said, I need to sell it. I'm losing money on it. It's costing me money. And his techs just couldn't grasp what they were trying to do on the machine with the problems they were having in the vehicles. And so they had stopped using the equipment. So valve bodies are technical, and they're not all the same. Even if you go and look at some of the simpler ones, which are like a 4L80, a 4L60, a 4T65, they're all kind of that same family, but there are differences. And you know, what's wrong in one may not always be wrong in the other one. So there's a lot of different problems you have, and you kind of have to learn each valve body by itself. And that's a process that takes time. There's a lot of knowledge there. It's not easy. The second thing that you're going to want to have is probably inventory. I look at this just simple things like replacement solenoids, harnesses, sensors for that. You know, a customer comes in, you know, they're looking for a fairly good turnaround, and with the way things are today, you can't always guarantee you can have something quick if you have to buy it and get it shipped. I heard something that last week that UPS over here was running like it took 2 or 3 more days to get something than it normally did. I wasn't sure why. So, you know, if you want to have some of that stuff on the shelf, so if a customer comes in and needs that car turned around relatively quickly, you can do that. Otherwise, they may take it down the street to somebody that can. The biggest thing, though, is the second part of the inventory down here, which I'm going to say are probably the valve body kits and the remanufacturing tools you need. And obviously Sonex, Transgo, and Superior, they're probably the most common ones. They make all the oversized valves or the replacement valves. And it's really the tools, the reaming tools you need to be able to go in and fix all of those wear spots in the valve bodies. That stuff is expensive. And if you're going to be buying, you know, maybe 3, 4, or 5 reamers for a dozen different valve bodies, I mean, that's gonna add up to be a significant amount of money, and to have those kits, you know, in stock or on the shelf, or at least enough to do your common valve bodies. So this is kind of what you kind of need to think about before you even get into looking at test equipment. So because you can be successful remanufacturing some valve bodies with really outspending a whole lot on test equipment to start with. A good example is over here, a 4L60 is still a very common valve body. It was put in a lot of pickup trucks by GM for many, many years. They're still used by a lot of people. So a lot of shops that I've talked to over here still say, yeah, we do a lot of 4L60s. And if you're going to get into do, say, valve body remanufacturing, that may be a really good one to start with. Most of the wear issues on there are pretty well known. You can do a Google search. You can talk with other shops. You know what typically wears out on these. So you could go and learn about this, have your techs learn about that valve body, do some research on it. Get the tools that you need to do the reman, get whatever oversized valves you want, the reamers and that, and you could say, well, I know that on this 4L60 there's 3 or 4 valves that typically always wear out on these, especially with the age these are all getting and the mileage they have over here. And you could go through and ream those out and rebuild those valve bodies, and then you could put them back in vehicles, and you may have a 70 or 80% success rate that when you do that works in the vehicle, and you have a 30% of them that give problems that you have to pull back out and do some more work on. So, but that'll kind of get you going with valve body remanufacturing. Now you've kind of got an idea of what we're doing, the process, you're going to work on it, you're going to learn that valve body, and now if you're going to start to go into doing more valve bodies, more complex valve bodies, that's when you start to think about, well, I need a better way to test it, because obviously the best way to test it isn't just to put it in a car and see if it works. That can be quite tedious and take a lot of work and a lot of headaches. So for valve body remanufacturing, the first place you need to look at is solenoids. And this has really become, I think, more of a big deal with the late model ones, because they're very expensive and there's a lot of them on valve bodies now. And solenoids are getting, you know, complicated to the point where you can almost say they're duplicating what's in the valve body. We have a solenoid with a very large valve attached into a housing that's now placed in the valve body, so you can see the same kind of wear characteristics in the solenoids as you see in the valve body. And you can't just tell always by looking at them if they're good or bad. And you could, yes, just say, hey, I'm just going to replace all the solenoids, throw them all out. And if you look at something like, say, something like a 4L60, a 4L80, a 4R70W, you do a study on that, you know, aftermarket or replacement solenoids are pretty reasonable. And it may not be even worth it to actually test the ones that are in there. It may just be easier just to replace it for the amount of money you're going to save. It doesn't really make sense. However, when you go to something like, say, an AS68 or 69 RC that has 8 solenoids on that are all very expensive, in that case, testing and reclaiming or reusing the ones that are not worn out starts to add up quite a bit. And that's definitely something you want to look at. So what I got pictured here are here's some more of your typical modern solenoids that are, you know, expensive. Shows one on a test block in one of our machines, and here's a graph of we're testing it. We're doing a pressure test. So this is a linear solenoid. We're ramping our current up here, and we're looking at our pressure curve and seeing if what we are measuring off of this solenoid matches a known good one. So, you know, that's kind of the process you'd go through if you're going to reclaim the solenoids. And what you're looking for is the ones that are bad. You're looking to get rid of those, test the ones, and the ones that are good, you can reuse them. Generally, regulating solenoids, either EPC pressure control or linear ones, they have a higher percentage of them are bad or worn out, where the on-off shift solenoids ones, they have a high percentage. I worked with a Reman several years back. We built a machine for them for just testing solenoids, and they actually did a study. This was on the rear-wheel drive Chryslers, the 42 to 48 REs, on the percentage of the governor solenoids they could reclaim versus the percentage of the on-off, the shift solenoids, the lock-up and the overdrive they could reclaim. And that justified the cost for buying a fully automated machine that could go and test those. So it was interesting to be a part of that. So valve bodies. When we get to valve bodies, what are we doing? We're identifying wear, we're repairing that wear, and then we're testing it. So as we know, valve bodies are a hydraulic component, and they control by using hydraulic pressure. It's all hydraulics. So all of you guys out there, you're kind of makeshift hydraulic engineers when you're working on valve bodies, whether you want it to be or not. So because they are a giant, well, not giant, but they are a very complex hydraulic piece of equipment. As we know, valves, and mostly it's the bores that wear on them. When they wear, we get leakage. The leakage between the valve and the bore, as that increases, we have trouble maintaining and controlling pressure in the different circuits, and that's what causes our issues. So what we're trying to do is find that wear and correct it. And the most common way is to buy any of these different kits, whether it's from Sonics, Transgo, Superior, and a lot of them, what you'll do is you go in and you'll take a reamer that reams out that bore to a slightly oversized, and then we have a matching valve that goes in there. So we're trying to bring that bore back to a round, smooth, known diameter that matches the valve that we're putting in there. And again, the most common way is to ream it out. So I've got a picture here, and not endorsing anybody by any means. You can use whatever kit you want, but this was a good picture that Sonics had of their typical reaming kits. You got a fixture here, you got reamers, you use a drill. They recommend you putting this like in an old parts washer so you can flush it and put coolant and lubricant across there as you're doing it. So that's going to be the process you're going to go through, reaming out the different ones. And then when you put the valve body back together with the new parts, you're going to want to test it and verify that you did fix what the issues were, or that your pressures are back to where they should be. Now, the other way you can do this, there are some kits in some of the valves where when they move, they don't wear the whole portion of the bore. You can get ones that have longer lands. That's a larger diameter portion of it that use some more of that hasn't been worn in it. So then you don't have to go through and ream it. You can just use a valve that's a little bit different configuration that uses more of the bore in there that isn't worn and gives you that sealing surface again. But that can't be done in all cases. In some cases, you don't have that ability, so then you have to ream it out. So. And those kits are available, like I said, from all the different manufacturers, and they vary depending on what they want, and you kind of use what you're comfortable with and what you have the most confidence in. So reaming, I do want to touch on this, since all those manufacturers do supply reamed kits where you have to go in and ream. And sorry about that. Sorry about that, guys. I just wanted to shut the phone off quick. So I want to just touch on that reaming is a machining process, and we have to think about it like that. What I got pictured here is a bore in a brand new valve body, and you can see how smooth and you can't really see, but I'll guarantee you it's very round. There's a good tolerance to that, and that's what we're after when we're doing reaming. It's a machining process. And I want you to think about it like if you've ever visited a CNC machine shop where they're machining parts in the big automated machine centers. And you want to think about how they're machining in there, and that's similar or the same way you kind of want to go through and approach this. Speeds and feeds are very critical when you're doing machining. Same thing when you're doing this reaming. To have a sharp and clean reamer is critical. So you want to have a sharp tool, you want it to be clean, you don't want to have anything stuck on it from the last time. Properly holding the workpiece is critical. You don't want to have one guy with a hand drill and another guy holding the valve body down trying to do that. You want to have a fixture. And probably the most important part of it all is lubrication and coolant. I've been to places where I've watched them do a ream, and they've got a spray bottle and they spray a couple squirts of fluid on it, and then they go through and they ream the whole thing. That's really not what you want, and it's going to be very hard to get the finish and the tolerance you want on this by doing that. You want to think of it like a machining process, and the more lubrication and coolant you give it, the better of a ream you're going to get. That helps kind of push away the chips that are coming out. It lubricates it so you get a nice clean cut, and really think about that as you're doing that reaming, because if you do a bad job reaming, you're going to have a bore that is going to be as bad or worse than you started with. It's just going to be bigger now. So I do have one question there about using a hand tool. Yeah, the Sonics kit, that one in particular I had shown, does show using a drill to do that, and you can do that. But again, you got to think about how you're feeding it and the speed you're going at. You know, you don't want to just grab a drill or a hand tool and go real fast. The better you can control the speed and the feed on there, the better. And it really depends on the volume. If you find yourself doing a large volume of valve bodies, a lot of places will buy like a milling machine, a Bridgeport or any other brand, and you can set up a fixture in there where you can go through and you can almost do it like a machine shop does. So, but to do 1 or 2 valve bodies, you know, even a week or a month, that wouldn't make a lot of sense. So, but just think about that. You know, think about that when you're reaming. That's what the goal that you're after, and the better of a ream you get, the better product you're going to have. So. And then obviously when you're done with that and you reassemble the valve body, the next step is to check your work. And again, we talked a little bit about you can go in there and say, well, I'm going to just put the valve body back in the vehicle and see how it works. And there are a lot of guys, when they're experimenting, they'll do that. You know, they'll say, we're going to try one valve, and then we're going to put it in the vehicle and see what issues we have. Then we're going to do the next valve. And that's kind of that discovery process you're going through as you're learning the valve body. What I got shown here is the Sonics makes this kit too, and I think there's a lot of places that distribute it. It's a vacuum testing kit. So what you're doing is you're putting a little plate, and a lot of these are made from plastic, I think, and put it on the valve body, and what you're doing is you're vacuum testing. So you're seeing I worked on this particular valve, and I can put this over and I can see I tested before and what kind of a vacuum reading did I get, and now I test it after I've done the repair, and if I can hold more vacuum, then obviously it increased it. And I think there's charts and stuff that they have where they say that this should hold a certain amount of vacuum. So that's one way to do a quick check. Obviously, since I'm from Hydra-Test, we're going to plug that the best way to do this is to use a valve body testing machine. And just to give you an idea of what you're looking for in any kind of valve body testing machine, because I do have a lot of people that call up and say, hey, do you have any leads or anything on, say, an old Answermatic or some other machine? And you know, there's a lot of those out there, but you really need to look at, if you're doing modern valve bodies, you know, it's not as simple. Okay, a 4L80, a 4L60 was relatively simple back in the day, as opposed to a 6L80 or any of the Mercedes or the ZF stuff. You know, we're at a much different level now of what's going on in the valve bodies. And with the valve body machine, what you're able to do is you're able to simulate what that valve body is doing in the vehicle. We're putting pressurized fluid to it just like the pump would be, and now we can actuate it through all the different gear shifts. And so we have that ability to vary pressure to the unit, so we can test it at different pressures, because sometimes using a higher pressure or lower pressure makes it easier to see issues on the valve body, or that we've corrected things. The ability, I think, is the big thing, and this is where I would steer people away from an old Answermatic, is the ability to actually graph what you're seeing. You know, in the ansomatic ones, and I know there were guys that got pretty good at when I worked with Zoom, is they would watch the gauges, and when a shift happened, they would know that, you know, this gauge is supposed to come on just a little bit faster than that gauge, or this one comes up than that one, and they knew that was good as opposed to, you know, a bad one. Well, now if we're talking about a 10-speed unit, that's a lot more gears, there's a lot more happening in between gears. You're not going to be able to tell that all just from looking at gauges. So to be able to graph out and actually see from one gear to the next gear to the next gear is a very useful way and a very quick way to see. You can kind of see in this one here, you know, the dotted line would be our master and the solid line is the one we're testing. You know, we're a little low here, a little low here, but here it's very obvious that there's something that's very different between the one we tested as opposed to the one we knew was a good one. So that's where we need to look. And then also having the ability to control the solenoids in the same way as the OEM did, to be able to go in and set the frequencies properly, to be able to ramp the current on and off. You know, we're not just turning them on, we're taking the current, we're ramping it from a low amount of current to a high amount of current over a certain amount of time to watch that gear shift happen. And then the other thing that's also important to be able to do is to go in and to isolate certain circuits. So it may be I actually set up a gear in here that doesn't really exist, but all I'm doing is stroking a certain valve that I know is a problem valve so that I can go in and actually stroke it back and forth a couple times and see did the curve look right or not, and kind of isolate those problem areas in that valve body. So, and any test equipment that you're going to get for testing valve bodies, that kind of stuff is very important. And so that kind of is the basics on valve body remanufacturing. So now let's take a look at a little bit of this in more detail on a couple of really good examples, I think, that kind of illustrate that. So we're going to go through and look at some examples of wear on a 4L80E and then also on a 6L80. So let's start with the 4L80E, and I want to just thank one of our customers, Bob at Valve Body Pro in San Jose, California. So he provided this information on a unit that basically we sent to him that someone had done a remanufacture on and wanted to see how good a job they did. And this was one that they need to do a little bit more work on because it had some issues. So it had some torque converter clutch circuit issues and some EPC solenoid issues. So first one was the torque converter clutch. And what they did, and I'm not sure why, but there was this portion right here. I think there's a pin that comes through from the back. They basically drilled this out all the way, so we had leakage here, and what that caused was low torque converter clutch pressure. So the way that he has his test set up, whatever his test pressure is he has going into the valve body, he knows when he turns on the TCC, he should see about 126 psi here. And on this one, we were only reading about 94 psi. So you can think about that. That's about a 30 psi drop on our torque converter clutch pressure. So what's that going to do in the vehicle? Well, if I don't have enough pressure to apply my torque converter clutch, it may shudder when it applies, it may not apply at all, it may only partially apply. It's going to obviously cause some torque converter clutch issues, and it's going to cause some fault codes. Not only that, you know, the vehicle may not be putting out the pump pressure that's going to have this at 126 psi when it's going down the road. This pressure could be maybe lower. I mean, maybe, you know, most of the time, or at some times when you're driving down the road, this is only at 100 psi. So now I've got 70 psi in my torque converter clutch, which really isn't a lot. So, you know, you're looking at this difference and what that's going to cause, you know, issues in there. So that one little mistake that they did is going to cause big issues on the torque converter clutch for this one. Moving on to the next thing in this valve body is you also found some significant issues with the EPC or the TV pressure in here. And this is an interesting one. I'll talk a little bit about this because you can also see this when you're doing solenoid testing, and there are some solenoids that have adjustments on them, but you can see here the dotted line is what we expect. Okay, so the green line is our pressure, and the red line is our current. So as we increase the current on this EPC solenoid, we should see the pressure drop. And if you look at this dotted line, it's smooth, the curves here, then we get this nice long linear portion, and it flattens out, and we get the same opposite thing on the other side. It comes back, we come back up here to about the same pressure we started with. That's what you're expecting. If you look at this one that we tested, you can see that the pressure was much higher most of the time. for the same amount of current. And we had a couple things here. I noticed you see this little dip right here. We also have that kind of duplicated on this side. So if it only been on one side, I could have said maybe it was some noise or something, but we can see it happening at the both sides of it as we decrease the pressure, increasing current, and increase the pressure, decreasing current. So that tells me that there could be some wear right here in this solenoid, and it's causing it to stick or something right here. Not only that, but you can see this curve is way out. It doesn't lay over the top of this other one. And the other thing is this would have been tested at the same temperature as the one we're comparing against. Our current is lower, so we're not seeing the same amount of current that we should, and we're seeing this curve shifted. So this is going to cause, high line pressure in this vehicle, which you'll notice right away on a 1-2 shift. If you've ever had any of these transmissions where they've gone into fail-safe and they've shut the EPC off and you got max mainline pressure on a 1-2 shift, you notice it right away. It's not a performance shift like back in the old days you did with your Chevelle where you put a kit in there to make a performance shift. It's a shift that customer is going to probably turn around after a few blocks and come right back and say, hey, why is this thing banging between each gear? And it's not good for any of the components internal to it. So, and interestingly enough, this actually looks like there could be a couple things going on here. Number one, this could be, and I would suspect this is a bad solenoid. There's an issue with this. But also there is an adjustment on the back of all of those old solenoids. There's a little set screw, and you can go in there and you can turn it. And I remember back in the day the thing was if you had problems with one of those, you just went in, you gave it a quarter of a turn, and then it would fix it. And that was what people said. The problem is that doesn't fix it. What that does is that pushes on the spring in there, and that pushes this whole pressure curve in tighter and tighter. And so, if this vehicle had been to say 3 different shops and everybody put a quarter turn on that to fix it, you're going to have something that might look like this. So when you do that testing on there, we could try dialing that back out and see if we can't bring this curve back out. But I still would suspect some issues here since we're seeing this little dip here and here, and we're not seeing the same amount of current. Interestingly enough, though, if you get to some of the later model one, the Asian Warner solenoids, the linear ones, they do have a curve that they need to be in to work properly in the vehicle, and they're not all the same even on the same valve body. So there is an adjustment on them. And so on our machine, what a lot of people do is they'll put that on there and they'll run a sequence that runs each one of those solenoids across, and they dial in that adjustment to get back to the curves, and so they can get those all, I guess you'd say, calibrated. If you buy them from the factory, I believe they're pre-calibrated, but if you're remanufacturing a unit, you need to calibrate those, because if they're off by too much, then the computer won't correct for it, and it'll throw codes and it has issues, and it's a very common thing. So so in this case, I think we had a bad solenoid, but in case of those Asian Warners, you can dial those in when you're testing. Before you run your final test, you're going through dialing all your solenoids in, getting them to match the curves, and verifying everything. So that was an interesting example there. And again, thanks to Valve Body Pro for that. And this one here was a valve body wear issue, was on a 6L80, and this one had an AFL valve bore wear. And this one is a really interesting case, and I want to thank Gary Walsh at Quality Transmissions in St. Louis, Missouri. So he sent this information over, actually sent us a couple of result files he had and some stuff that he had played with. So here's the AFL valve in this 6L80, and what it was is this bore was worn, and I got the hydraulic schematic here out of the GM book so you can look at. So and excuse my picture over the top of the corner here, but that shouldn't really affect too much. So what you're seeing here is the pump pushes fluid up to this AFL valve, and this regulates our pressure, and we get this actuator feed limit oil, and this feeds, if you look at it, comes down and it feeds all these different solenoids in the transmission. So the pressure that this valve knocks the pump down to is critical because it's feeding all the different solenoids, our shift solenoids, our lockup clutch. So if we have an issue with that AFL valve, we're going to have issues probably everywhere. We're going to have harsh shifts, we're going to have soft shifts. We can get solenoid codes because it's expecting a certain pressure to be here, and then when I turn that solenoid or ramp it on and off, it's expecting a certain thing to happen, and when it doesn't, it's going to maybe not suspect the pressure, it's going to suspect the solenoid. We can get wrong gear starts, we can get clutch failures, you can get all kinds of problems coming in just from this one valve. So when we put it in the machine and we did a test on it, if you look at here, so the black lines here are our machine pressure. So what we did is we started out around 10 bar, and then this was kind of the end of one test, and then we bumped it up to about 15 bar for the next test. So typically what we have set up on our machine is do a low pressure test, a medium pressure test, and a high pressure test. So what they'll do is low pressure test will run through all the gears, we'll cycle the EPC up and down, or any of the pressure regulating ones that we can, then we'll move the pressure up. So this is kind of the end of one and the beginning of another, but I think it illustrates it pretty well. The 1B is it's the AFL valve. Let me go back to that. I had one question here. So 1B is the actuator feed limit valve, and that's the pressure that goes to all of our solenoids. So it comes off the pump, goes through this actuator feed limit valve, and the output pressure for that feeds all of our solenoids. But again, as you can see in here, so the dotted line, red line is where we expected it to be based on a known good unit, and it would run at right here is about 121 psi, 8.4 bar. This unit, when we ran it, we were trying to hold it at the same pressure. We could see we were down here at 7.3 bar, 106 psi. So we had all across the board on every gear shift, we had about a 15 psi drop in pressure. So this is the oil that's feeding every one of our solenoids in this transmission, even though our input pressure was the same. So we're holding our input pressure the same, but our output pressure from that valve is about 15 psi lower. So let's look at how that affects all of our different clutch pressures. So I've added the 1, 2, 3, 4 apply pressure in here, so it's the darker red line. So you can see we expect that to kind of match the AFL pressure, but it's following this lower one. It's matching it, but it's low. We're about 15, maybe 20 psi low on that pressure. If we go to the next one, the 2.6 apply pressure, same thing. This is the gray line now. So they're all lower across the boards. We go to 3.5 reverse apply pressure, same thing. We're expecting it to kind of match that. It matches it, but because we got that lower pressure, again, dotted lines are what we expect, and the solid lines are what we actually measured on this particular valve body, and we're keeping our input pressure about the same. We're holding that at that 15 bar. We have a significant drop. And our 4, 5, 6, so this is the green lines here. Again, this is lower. And the next one is interesting too, because now we're looking at our torque converter clutch apply. Think a little bit back to that 4L80 what we were talking about when we had lower torque converter clutch pressure. Same thing here. Our torque converter clutch pressure is now 15, 20 psi lower than we would expect it to be. So we can see the same kind of apply issues with our torque converter clutch. Now we're having lower pressure, we can get shudder, and especially in this unit, because this isn't a unit that just normally just applies and releases the torque converter. They're going to slip that torque converter on. It may not be fully on all the time, so you can see a lot of torque converter clutch issues. And the last slide here, I think, is really the one that's important. I think this is really the one that gets you to the heart of what the problem is on this one, with just having this one valve that has an issue. So this is the between 5th and 6th gear. This is we're shifting to 5 and 6. Okay. So the dotted line here again for the test conditions we set up. Now this may not be exactly like it's in the vehicle, but it doesn't really matter because what we're doing is we're applying a certain set of test conditions and we're comparing one that we know was good versus one that we're trying to decide is good or not. Okay, this line that goes across here, when you look at, that's where the dotted line of the off-going clutch versus the ongoing clutch cross. And so if we say right about here, looks like it's about maybe 3 bar, let's just say that's where the one clutch releases and the other one applies. Okay, with this one that has a lower pressure, we've got about a 0.12 second gap in between there now. So what's more than likely going to happen in this, unless the computers can adapt and fix this in the vehicle, is we're going to cause a flare, because the one clutch is going to drop off and we're going to have basically a slight neutral condition for about 0.12 seconds before the next one can grab. And as this pressure drops, that's going to get worse and worse, and so you're going to see flares, momentary neutrals. It could also cause things in some cases where you have binding, and if any of you have ever experienced that in a car, it's not something you want. So all that comes back to the fact that we just had that one valve was worn. And this is where you can actually see this on the machine. You can see, well, I know that a good valve body, I should have this cross point about here all the times. On this one we tested, it was very obvious that it's not, and this is going to cause a problem. So it's not so much I'm looking for the problem in a particular gear. It's not just I'm looking for what's going on in 5th gear, in 6th gear, in 1st gear. I'm looking for what happens between 1st and 2nd, what happens between 2nd and 3rd. And this year you can really see that there was a big difference between that. And again, computer can adapt to stuff. They have a learn mode, and this one especially, I think it's a continuously adaptive mode, so it can adapt to this kind of stuff for a while, but eventually when it gets to where it gets great enough, it just says, okay, well, there's something wrong, and it's going to throw a code and go into failsafe. And this is here you can verify, did I repair this? So after you replace this AFL valve, ream that out, put one in, you should see this come back to this other curve we had on this test. And this may be something you go through and you do a little bit more work on this test and that portion of it to really kind of isolate that, because if that's an issue that's very common on these, you want to make sure that you fix that. So we're getting to about the time here. So we've just to kind of wrap up, we kind of looked at the whole picture when it comes to valve body remanufacturing. For those of you that aren't real familiar with it or are thinking about doing it. And I think we kind of dug in a little bit, looked at a couple of really good examples of where and how we can see that on a 4L80, which is a pretty simplistic case, but also on a 6L80, which is more of a modern one that a lot of people are especially seeing here. So and just kind of looked at how we can see that and how we can, after we fixed it, what we're looking for. So hopefully that was of some use to you guys. You got a little bit out of that. And I'd like to thank you all for attending. I'd like to throw it out there that if any of you have an idea or maybe a technical problem you work through with a valve body that you'd like to share with us that we can present an upcoming webinar, I'd like to do that. I've also got a number of solenoid specific topics that I'd like to put together, so we're probably going to look at doing some of those in a webinar, just kind of focusing on solenoids and taking that, because there's a number of different things you can do with that. But yeah, reach out to us. I'd like to know what you thought of this webinar. Was it useful to you? Would another time of day be better I know for everybody that's outside the U.S., we could probably do this at a later time, our time, which would be morning for you guys or something. So if that's something that really we have a lot of requests for, we can do that. We can actually redo this webinar again at a time that's a little bit better for those of you outside North America here. But yeah, any topics you'd like to see, definitely let us know, feedback. And then any questions on our equipment, or if you're interested in it, this here's the number I have. This is our sales office for the U.S. and Canada. My email address, so 262-563-1048 is our number. If you're outside Europe or anywhere else, Sam is our guy that handles sales there, so this is his number or his direct through WhatsApp, or you can email either of these and they'll be able to help you too. So I'm going to wrap that up, this portion of it, for any of those of you that want to get off of the webinar and get going. I will leave this up for a little bit yet, so maybe for another 15 minutes. So any of you that want to ask any questions in the chat window, I'd be more than happy to answer that. So there is a little bit of a delay. I think it's probably about a 30-second delay or so. So when you ask the question, it might take me just maybe 30 seconds to respond, and it's just the delay we have, even though this is live. It's live but delayed, kind of like how they broadcast TV these days. So, okay, and that kind of wraps it up. So thank everybody for attending, and any questions I'll kind of answer down below here. So we had a couple here during it, so I will start with those. And again, any comments you want, feel free to throw them in as well. So. So we did have one question here about pricing. How much is it? I'm assuming you are talking about the valve body tester itself. So it's going to vary a little bit depending on shipping to get to you and where it's coming from. So for United States here, our pricing is around just under $40,000 for a complete machine. So that's the one that we showed in there. Let me see, I can go back to it, kind of show you the picture of it, what it comes with. So for the US here, a couple more slides. So we got a couple questions. So this machine here is our standard machine. So just under $40,000 for the machine. It comes pretty much as you see it. So it's got the software installed, pre-installed scripts, kind of everything you need. What it doesn't have is the adapter plates with it. So it's the machine, the software, everything there, and then the adapter plates run probably around $1,800 a piece, depending on which one. Some are a little bit more than that. It kind of depends on the plate for each one. So that's about the price of the machine. Other places it might be a little more, a little less. Again, it depends on the shipping to get to your country and all that kind of stuff. But that's what we're kind of running at right now. That also has to, some of that has to take into account customs and all of that stuff there. So, but yeah, a little under $40,000 for the complete machine, and then the plates, you add them as you need. Our Solenoid machine is about $12,000. That's the machine, the computer, the software, pre-written scripts to get you started, and the blocks are around $300 a piece, plus or minus. The one thing, if you don't have real high volume, you can use the valve body tester. We have an adapter plate to put the solenoid blocks into here. So if you don't if you don't have to worry about running into an issue where you're tying the machine up testing solenoids that you need to be using it to test valve bodies, you can use that one machine for both of them, and a lot of customers do that. But if you do have a higher volume, then it makes sense to have, separate machines. But if you start out with, say, the valve body machine or the solenoid machine, the blocks can go, the solenoid blocks can go in here with an adapter plate. So, so there's that. So another question we got here. I was under the impression that the valve body testing units were more for checking the repairs before reinstalling the unit into the car. Yes. So that's generally what what our customers do with the valve body machine is after you're done doing all the repairs on the valve body, you run it across the machine to do that final check before you put it in the car. You don't want to, and kind of talked about that. Talked about that a little bit, where you can use the car as a way to kind of diagnose it if you don't have the machine itself. But the real key is if you're going to spend the money on the machine, you're going to save that time in the car. And that's some of the comments we've had, is that a lot of guys have found a lot of problems on the valve bodies that they would have put back in the car and had to troubleshoot and then pull that valve body in and out of it. So it's saved them that by the time they put the valve body in the car, that they know it's going to work, most of the time, that any issues they have are either not the valve body or the transmission related. So you're able to kind of do that final check and make sure everything is 100%. You're not putting in the car and, okay, I've got a drivability issue, I've still got codes. Is it still my valve body? Is it something else? Or is it something simple that we missed that, we took it back out and, oh, well, we should have caught that. So yeah, the valve body machine is that final check before you put it in the car. What you really don't want to do, you start a little bit with this as you're learning it, is you're going to be putting valve bodies you've pulled out of the car in here to try and see those problems. But after a while, you want to get to know the valve body well enough that you go through and you know that on this particular valve body, these three valves are always worn. I'm going to do that, and this becomes kind of a final check. You don't want to get to the point where you're putting valve bodies on and off, on and off, on and off the same valve body, because that's going to take a lot of time. So you kind of get to learn those valve bodies. But one of the feedback that we did get from the machine is one guy who was doing valve bodies without the machine. He said, I found that I was replacing a lot of stuff in the valve bodies that I didn't need to by using the machine. I was just assuming that these valves were worn, and they weren't all of the time. So he actually started putting less stuff in the valve bodies, and he would check it and find that, oh, this particular one does have that issue where maybe the three before that didn't. So there's that. Answered that question. Let's see. In the future, will the webinar be like this, but in the Russian language? We probably, well, I don't speak Russian, so sorry about that. But we do have some people at our office over in Europe that do speak Russian, so we may be able to have them take this webinar because it will go up on our YouTube channel, and maybe they can have it converted over to Russian. I'm sure there's some apps that do that, or we can do subtitles in Russian too. Obviously, I know that would be helpful for you guys that English isn't your native language. So another part here, what about the Pro Access reaming machine? Do you think you can save money and less need of reamer kits from Sonics? Again, I'm not going to endorse anyone in particular. They all make different ones. I've seen the Pro Access stuff. I know that that's something that they've done a lot of good work on, and I've seen how they do it. I like that, where you're putting it into a Bridgeport and you're doing it. Again, it's more of a, if you're doing a fairly large volume of stuff. But again, any way that you can do that reaming, which is a machining operation, similar to a machine shop. It's all comes down to, I'm reaming out this hole, and if I do a bad job reaming it, I'm going to have marks in it, I'm going to have leakage in it. So we want that hole to be as close to a finely machined hole as possible. So, in a lot of this industry, they started with the different reamers, and that is, well, you don't want to have somebody have to go in and spend thousands and thousands and thousands of dollars just to do one valve body. So they tried to do it as easy but to get a good result as possible. So yeah, I've seen the Pro Access stuff and the machine they have, and it's nice stuff. So but again, that's all that other investment. We sell the test equipment, we want to sell you the test equipment, but you got to look at the other investment, all the other stuff you get. I talked to some customers and I've said, this is what our test equipment costs, but you could spend just as much of that on all the other stuff you need just to get started. So if you're budgeting to get into doing valve bodies, think about the big picture you want, not just call us up and, okay, well, it's going to be $60,000 for some test equipment. Well, what's the other things that you need? So. Oh, okay. Another question here about using the test machine as opposed to vacuum testing. Yes. The machine there will be able, you're able to go through and you're doing pressure checks on the whole valve body. So, and you can go in and, like our one customer here, Valve Body Pro, he does a lot of stuff where he checks certain pieces of the valve body. So not just always doing a whole complete test. He's looking at, things that typically wear on that. So you can do that. Again, it's what you have the ability to do. With the solenoids, I have a valve, and if I can actuate that valve back and forth through its range with turning one solenoid on and off, well, now I can set up a test. And that's part of when we sell you the machine, we come out and train you on it. We train you how to go through and how to write your own tests. We have ones that are pre-done in there that we've collected from different customers we went to, but we train you how to actually write your own tests. So you don't have to use what we have. You can completely write one that's all of your own when you get into it. So, and that's really the power of that. I can write my own test and graph out, and I'm going to take a known good one. I could buy one from a dealer. I could take one that I've remanufactured, and I know this is a good one, works in the vehicle, and now I have this one, so I can have a couple different things to compare against. What would one be, a brand new one from the dealer versus one that I remanufactured? I know works good. What are the differences there? And now what are the differences with the ones that I'm trying to reman, in the shop, or when I get one that I brought in on a vehicle that has issues, well, now I can put it in the machine and compare it, and I can look at, okay, well, this had these different codes. How do I link those codes back to something in the valve body? So yeah, you can use the machine to do that. I guess I call it R&D and discovery work as you're learning the valve bodies. But yeah, you wouldn't have to go do vacuum testing and then come to the machine. The vacuum testing is kind of an easy way to check things real quickly if you don't have a machine or before you get a machine. Just because again, like I said, you can take that valve body and do all the work to it and put it in the car and see if it works without testing it. But the best way is to do testing, and it really depends on how much you want to invest into that. Vacuum testing is a pretty low-cost investment, and it's not perfect, it's not comprehensive, but you can do a lot of quick checks on that, so that you're just kind of verifying stuff. Or if you want to put the investment into buying test equipment, like our valve body tester, it's an investment, but now you have the ability to really be able to test and to isolate, a lot of different things, and not only that, but have a record. So as you do this testing, all of this stuff gets recorded, and you build a database of records on there. So you have a record of every valve body you've run across there. And so as long as you organize that properly, you can go back and you can organize those into maybe vehicle types or different update kits that you did. So maybe you went through and did a bunch of valve bodies with Sonics kits, and you want to have that as part of your database. Now I did some different valve bodies with Transgo kits, different kind of reamers, so it gives you that ability to do that. So and record all that stuff and have that for the future. So. Yes, we could probably do Russian subtitles, so it would take a little bit. I don't know how they would do that off the top of my head, but I will bring that up to Sam. He'd probably be the one that would be heading that up, and maybe we'll put the Russian subtitles on this one once it'll be up on YouTube. So if there's any of you guys that couldn't make the webinar or wanted to go back and watch this again, or have anybody else there, this will be up on YouTube on our channel. So. I guess, is there any other questions? Otherwise, I'm going to wrap it up and say goodbye. So have a good rest of your morning, afternoon, or evening. And we'll hopefully we'll have another one of these coming up within the next month or so. And maybe we haven't decided yet. I know with the ATRA show being canceled, I don't know what their format is. They're still going to do a virtual expo. So I don't know if it'll be something similar to this or a Zoom call or how we'll do that, but that'll be in November now, I guess, for those of you that haven't maybe got the official information on it. So we're going to do a virtual, some kind of a expo in November. So we'll have something set up so we can answer questions and show you stuff about our equipment and be there and maybe just stop by and say hi. So, but it'll hopefully be something we can talk back and forth. Now this one is just, there's the chat box and it's just me talking. So that'll be something a little bit more interactive. So. Right, seeing people from all over the place here. Japan, looks like Russia. I think we got Spain in there somewhere. So it's kind of good to see you guys there. So thanks for attending. Okay, no other questions. I'm gonna end the stream and we'll see you hopefully in the future. So thank you again.